Hi all, my name is Nitin. So in my last session of Docker part 1, I was going through this small exercise to create a Python Flask app and run it in the form of container. So let's go through that. So as a part of this exercise, we should have some files and directories to be created, so which I have already created here, and I do have app.py here. Let me go through that. So app.py is Python code basically. So here what we have been using Flask, importing few libraries like random, Flask, and we have images location over there. So that's my Flask Python program, very simple one. And next is about my requirement file. So in my requirement file I do have a single requirement, that is Flask version. So it should be 0.10.1, and inside slash templates I have index.html. So let's go through the Docker file, which is very important file. So here I'm using Alpine colon 3.5. 3.5 is the version of Alpine. So I'm using this as a version of this as a base of my image basically. So this is my base image, which I'm going to customize as per my requirement. So I'm going to install few packages like Python or pip, right, which we are going to install, and we are also adding few requirements to the users src slash app directory, and I'm going to install my requirement that is Flask 0.10.0. I'm going to install that as a library on my image, on my customized image, and I'm going to copy app.py to this location, also copying index.html to this location, finally exposing the port 5000 on which my application will be running to the outward and running my Python program, right? So this port will, the service will run at this port, and 5000 port we are gonna map to our host port, which we will use to see our application on browser. Okay, so let's build the application now. And to build the let's build the image, Docker image now. The command to build the image is basically docker build -t, the name of your image, like let us say my app dot. So it will build your image, right? So while building, what it will do, it will download your Alpine, that is the base image, right? So it will use this as a base image, it will download this one and perform the rest operations which you mentioned in your Docker file, right? So it will perform all these actions and create one more Docker file, that is my app, right? So my app image has been created with the tag latest. So what is the next step now? Next step is basically to run your container. So to run your container, that's the command which you need to run. So let's copy and paste it here, and here my image name is my app. Let's run it as is, and it says running on port this, right? My EC2 machine public IP address can be used to see the application on the browser. Let's go back to browser now, and my machine IP address is 3.82.187.104, and the port where I mapped my application, container application, is 8888. So see, my cat pics are coming, so it means my container is up and running fine, right? So if you interrupt it from here, and if you go back to your browser and try to hit it again, it is not visible now, right? So my container was running, and now I interrupted it. So where it should go now? It should go in docker ps-a, and it should see me the status as exited. That's what it is showing, right? So the status of the container is exited. I can see everything whatever I was expecting. So now The next step is basically to push and pull the image from Docker Hub. So for that you have to have a login created in your Docker Hub, right? So let's go back to your Docker Hub and create your credentials, sign up into the Docker Hub. For me, I just signed up to the Docker Hub, and you can create your repository here. For me, I have already created a repository called training. So inside Nitin console/training, you have one tag already there. Tag name is latest, right? So it means one image is already pushed to my repository. So I wanted to push one more. So what you can do, for that, first you have to authenticate to the Docker Hub from your Docker host. How will you authenticate? The command would be docker login. So it will ask for credentials for your Docker Hub. So here is a credential. I'm logged in. So it says login succeeded. So now I do have image. The image name is my app, which I want to push to Docker Hub, and the command to push the image to the Docker Hub will be my app. But you cannot push it like this, right? Otherwise, what it will do, it will try to look for the repository name my app into the Docker Hub, which I don't have. My repository name is training, right? So in fact, not training, my repository name is Nitin console/training, right? That's the name of my repository. So what you should do, you can create one more repository, or let's create one more repository, okay? That will be easier one. So here you can say my app, description cat pics, okay? And let's say this is public, which you are going to create, and say create. So this is my new repo which I just created inside my Docker Hub. Let's go back to your putty session, and you have to run command like this: Nitin console slash my app colon tag name, if any. So if it is latest, then latest. But to run this command, there is no such image exists, right? So what I should do, I should create a copy of existing repository. So how will I do that? I would tag it basically, okay? Docker tag my app to Nitin console/my app colon latest. So let's tag it, and if you run this command now, it will show you one more copy of your image, and the copy name is Nitin console/my app. The tag name is latest, right? Now directly I can just run this command to push my image to the Docker Hub. See, it is being pushed to the Docker Hub. Let's go back to the Docker Hub and refresh your page and see if something is there or not. It says last pushed a few seconds ago. It means, see, latest has been pushed to your Docker Hub. So image has been pushed to your Docker Hub. So now the next exercise is basically to pull the image from Docker Hub. How will you pull it? So let's remove everything whatever we have, right? So let's run the command using -force option. Remove everything whatever we have, Nitin console/app. Okay, let's remove it. And Alpine, let's remove it. For Alpine, we cannot remove it by just mentioning Alpine, because it has tag name 3.5. So by default, when you are running RMI command, it will expect the tag name as latest. If the tag name is not latest, then it will then it has to be mentioned explicitly. Okay, so for other one, if you mention colon latest or not, doesn't matter. But for Alpine, we have to mention tag name explicitly. Okay, let's remove it. Everything has been removed except CentOS. So there is no container running, there is no Yeah, so I think there is one container running, there is one container is in exited state, and that was some intermediate one, so you should not be worrying about that. Okay, that was my other container. Okay, so we are good. I have removed everything. Now let's pull the image from my Docker hub, and my image, the repository name was my Nitin console slash my app. If you want to specify letters, then you can pull, right? So it says I was able to see my image now, right? And this image was created when it was created 7 minutes ago. The size of this image is 57.1 MB, and this is the latest one. And if you want to run your application once again, the command would be again same, docker run -p my app, and not my app, this time the image name is this one. Hit enter, it will show you this is as a running, and go back to your browser, it will show you application is back. So this way you can push and pull your image to and from your Docker hub, right? Very easy, simple one. So now let's talk about some security in Docker. The security is basically some Linux kernel file system have to be mounted in a container environment, or process would fail to run. So when you launch a container, basically I have one more image over there, and the image name is sent to us. Let's use that for this to understand. So what I'm doing, I'm just going to log in into CentOS container, okay, by running docker run -it CentOS. So I'm logged in to the container, and if you see, this is CentOS container, and if you see, there are few file systems which are coming from my host. If you see, these are all coming from my host, and these are all, I'm here logged in as root, but I cannot do anything here within these file systems, and these are basically coming from Docker host, so ideally I should not be able to do anything inside the file systems which are shared from Docker host, and these file systems has to be mounted to launch a container basically by Docker. So if you see, let's read this line once again. Some Linux kernel file system have to be mounted in a container environment, or process would fail to run. Fortunately, most of these file systems can be mounted as read-only. Most apps should never need to write to these file systems. So Docker, when launch a container, the file systems which are coming from Docker host will be shared in a read-only mode, so that nobody can play with the file system or can create or delete anything within the file system, right? So this is first point. Second is basically copy on write operation. So Docker follows copy on write operation when writing onto the file system. As I said earlier, the difference between image and container is that top writable layer. So when you write something to the container, everything is being written to the top writable layer, and the underlying image remains unchanged, right? So basically multiple container can share access to the same underlying image and yet have their own data state, right? So let's discuss about problems in Docker. The problem is, Docker provided an open standard for packaging and distributing containerized application. These arouse a new problem. The problem is, how will you maintain the coordination between the containers, because you may end up with launching few containers, like you may have one application container, then web container, you may have some database container, right? So these containers should be communicating to each other. How will you handle that coordination, or orchestration between the container. How will you scale your container? How will you scale down your container? How will you maintain the replicas, right? So these are all problems with Docker uh, which are being handled through the orchestrators tool like Docker Swarm or Kubernetes. So maybe in my upcoming sessions I will come up with sessions on discussion on Kubernetes. I will show you how to scale up container, or how to scale up your application, how to distribute the load, right? So and how to connect one container to the other container. So those kind of problems will be taken care, will be handled through these kind of orchestrators. Okay, that's it for today. Thanks. Happy learning. Thank you.